In section 5, we're going to talk about angles of elevation and depression, which are helpful when solving word problems that have to do with right triangles. So when we talk about an angle of elevation, it's the upwards angle from the horizontal to a line of sight to some point of interest. So if an angle of elevation is an upwards angle, an angle of depression would then be a downwards angle. So it's the same definition, but instead of upwards, it's downwards. So it's the downwards angle from the horizontal to a line of sight to some point of interest. I'm actually going to draw a small picture so you can see what an angle of elevation and angle of depression look like. So draw a stick person here. Okay, the horizontal is just the line created from they look straight out. And there are two objects. We have one above them and one below. So looking up to that object, the angle created is our angle of elevation. Okay. And when we look down at an object below, that's how we get an angle of depression. It's just an angle either looking up at something or looking down at something. So let's go ahead and classify some angles as either angles of elevation or depression. So the first angle here, we're at the top of a tree, and then the horizontal is going straight across, and then our angle is going down to a person. So angle 1 is an angle of depression. Okay, so next, angles 2 and 3 are based on the line of sight of our person. So our horizontal going straight across. So angle 2 is created when we look at the top of the tree. So angle 2 would be an angle of elevation, whereas angle 3 is when we look at the base of the tree. So angle 3 would be an angle of depression. That leaves us with angle 4. So from the base of the tree, the horizontal goes straight across. So from the base of the tree to the person is where angle 4 is, which is an angle of elevation. So depending on where your horizontal is and depending on if the angle goes up or down, that determines whether it's an angle of depression or elevation. So let's go ahead and do some examples. So you are measuring the height of a building. You stand 100 feet from the base of the building. You measure the angle of elevation from a point on the ground to the top of the building to be 48 degrees. Estimate the height of the building. So when you're solving a problem that involves angles of elevation or depression, they're typically going to be word problems. And if a picture isn't already drawn for you, it's always a good idea to draw a picture so you can see what it looks like. So I'm going to draw a building here. And then we are standing 100 feet from the base of that building to a point. And we know the angle of elevation from the point on the ground to the top of the building is 48 degrees. Now the angle formed with the ground in the building is going to be 90 degrees. So our distance from the building and then the angle of elevation to the top creates a right triangle. So if we want to find the height of the building, we're basically solving for one of the sides of our triangle. So figuring out opposite versus adjacent, we have the height of the building as the opposite side and the distance we're standing away from it being the adjacent side. So we're going to use a trig ratio. So right SOHCAHTOA. So the trig ratio that involves opposite and adjacent is tangent. So we know tangent of 48 is going to equal our opposite side, x, over our adjacent side, 100. So we're going to put tangent of 48 over 1 so we can cross multiply to solve for x. So we get x equals 100 times the tangent of 48, and we get that x equals 111.06. And now because we are talking about the height of the building, we need units here. And in this case, the units are feet. So the building is 111.06 feet tall. Next, we have that a driveway rises 12 feet over a distance d at an angle of 3.5 degrees. We want to estimate the length of the driveway. So we have our starting point. Driveway rises 12 feet. So the distance the driveway is risen is the 12 feet. We have our angle 3.5 degrees, and then the length of our driveway is our distance d. So if we label our sides, we have the opposite side of 12 feet, and d, in this case, if we draw our right angle, is our hypotenuse. So the trig ratio that involves opposite and hypotenuse is sine. So we know sine of 3.5 is going to equal the opposite side 12 over d. That is our variable in this problem. So put sine of 3.5 over 1. When we cross multiply, we get d times the sine of 3.5 equals 12. Divide both sides by the sine of 3.5, and we get that our length of our driveway, d, is 196.56, and again, we will need units in this problem, and it is feet again. So we have a similar problem to the first. We are measuring the height of a tower. You stand 154 feet from the base of the tower. You measure the angle of elevation from a point on the ground to the top of the tower to be 38 degrees. Estimate the height of the tower. So this is going to be a pretty much identical picture to the first problem. We have a tower. We are 154 feet from the base, and our point from the ground, the angle of elevation from the point on the ground to the top of the tower is 38 degrees. We want to find the height of the tower. So we still have the opposite side, x, and our adjacent side of 154. So we're going to use tangent. So tangent of 38 equals x over 154. So we're going to put tangent of 38 over 1 so we can cross multiply. So we get x equals 154 times the tangent of 38. So x is going to equal 120.32 feet. So the height of the building is 120.32 feet. So not only can we use angles of elevation and depression to solve for side lengths, we can also use side lengths to solve for our angles of elevation or depression. So we want to find the measure of the angle of elevation of the sun when a vertical post 15 feet tall casts a shadow 20 feet long. So if we draw our picture, let's draw our sun here, and let's draw a post. So the sun casts a shadow on this post and meets with the ground. The height of our post is 15 feet, and then the length of the shadow is on the ground, and that's where our 20 feet goes. So the angle of elevation is the angle that the ground makes with the shadow to get up to the sun. That's where our theta is going to go. So if we figure out what sides we're given, we have the opposite side of 15 feet and our adjacent side of 20. So we're going to use tangent. So tangent of theta equals 15 over 20. And in order to solve for an angle measure, we use inverse trig functions. So we're going to take the tangent inverse of both sides. So using a calculator to evaluate the tangent inverse of 15 over 20, we get that the angle of elevation theta is 36.87 degrees. In our last example, we have a 40-foot ladder leaning against a wall, reaching the wall at a point of 36 feet above the ground. Find the measure of the angle created between the ladder and the ground. So again, drawing a picture, we're going to have a building and we're going to have a ladder. Leaning against the building. So we know that the height of the building is 36 feet. And the length of our ladder is 40 feet. We want to know the angle of elevation, well, the measure of the angle created between the ladder and the ground, which in this case is going to be an angle of elevation. So we want to solve for theta. So 36 feet is the opposite side, and 40 feet is our hypotenuse. So the trig ratio that uses opposite and hypotenuse is sine. So we'll have sine of theta equals our opposite side, 36, over our hypotenuse, 40. So to solve for theta, we'll use an inverse trig function, and it's going to be sine in this case. So we take the sine inverse of both sides. So using a calculator, the sine inverse of 36 over 40 is going to give us an angle of 64.16 degrees. As you can see, most of the trig ratios that we used for angles of elevation and depression were tangent and then with some sine. Most of the time you're going to use tangent. Not all of the time, but most of the time we're going to use tangent when it deals with angles of elevation and depression. As you're working on the assignment, if you need any help in drawing your pictures or figuring out the lengths you're given, please ask me so that you have the correct picture, so that you use the correct trig ratio when solving for either an angle of elevation or depression or a side length.